Hi class, today we are going to do Unit 1 Lesson 5 and we are going to apply the trigonometry to actual real life problems. So we're hoping that you can find missing sides and missing angles of isosceles triangles and that you can apply right triangle trigonometry to application problems. Real quick, a reminder of what an isosceles triangle is. An isosceles triangle has two congruent sides, and remember the angles opposite them are also congruent. So if I go opposite of this side and opposite of this side, those two angles down there are also congruent, and those are called the base angles. And then the other angle is called the vertex angle. So you can see the vertex angle up here at the top. Number 1, an isosceles triangle has legs 16 meters in length and a base of 6 meters. Find the measure of each angle of the triangle. So you know me, I always like to draw this out. So I'm going to draw a picture of an isosceles triangle. And it says the legs are 16 meters. So that's the two congruent sides. The base is 6 meters. Now remember, the two base angles would then be congruent. And so we want to find the measure of these angles. What I'm going to do is I'm going to drop down an altitude or a height here so that what happens is I get two smaller triangles, but they're right triangles, and then I can use SOHCAHTOA. So instead of having 6 meters across the bottom, I'm actually going to erase that, and I'm going to change that to, this is 3 meters and this is 3 meters. So altogether it's 6 meters. They will be split equally because it's an isosceles triangle. All right, so next, let's call one of these angles theta. So I'll call this angle down here theta, and I'm going to try to find theta first. So imagine we're just going to use one of these right triangles. I'll highlight it in pink here, or red. Let's use that triangle, and let's try to find theta. So look at the sides that we're given. We're given the 3 meters and the 16 meters. Figure out what sides you're dealing with. I think the 3 meters would be considered adjacent, and the 16 meters would be considered hypotenuse. Think about SOHCAHTOA and pick one of your ratios. Pick the one with adjacent and hypotenuse. So that's cosine. So we're going to go cosine of theta equals adjacent over hypotenuse. So 3 over 16. Hey, we know how to solve this. To get theta by itself, you have to do inverse cosine so that it gets rid of the word cosine. And you're going to wind up with theta equals inverse cosine of 3 divided by 16. And then that you can type directly into your calculator. You should get 79.193. Again, make sure your calculator is in degrees. So this is theta. Now remember, in this triangle, we have two base angles and they're going to be congruent. So this other base angle will also be 79 right here. This one will also be 79.193. Together in the original triangle, the corners or the angles have to add up to 180. So think about 180, subtracting out your 7.193 and the other 7.193. Let's see what we have left. That should come out to be 21.614. So that angle up here at the top of the triangle, that is 21.614 from the original triangle. So just to conclude here, the angles in this triangle are 79.193 degrees, 79.193 degrees, and at the top 21.614 degrees. You could double check this and make sure they add up to 180 just to be sure. Example 2. An isosceles triangle has base angles of 80 degrees and a base with length 10. All right, so let's draw this again. Isosceles triangle means two equal sides. Base angles of 80 degrees means these two down here would be 80. This would be 10 centimeters. Find the perimeter of the isosceles triangle. So in other words, I'm going to have to try to find the length of these two sides. Now granted, they will be the same length. In order to do that, I want to get a right triangle. So I'm going to drop down an altitude here, or a height, and I'm going to think about this 10 at the bottom. I think it would be divided into 5 centimeters and 5 centimeters since it's an isosceles triangle. Now I can use half of the original triangle. For instance, I'll use this side right over here, highlighted in red, and I'm going to try to solve for x using trigonometry. So think about your 80-degree angle. Here's your 80-degree angle. What side is the 5 to that angle? Opposite, adjacent, or hypotenuse? It is adjacent. The side that we want to find, x, is the hypotenuse. Think about SOHCAHTOA. And you're going to choose one of these. You want to choose the one that has adjacent and hypotenuse. You're going to choose cosine. So you're going to go cosine 80, remember it's always the angle that goes in there, equals adjacent over hypotenuse, 5 over x. Solve this, so we're going to have to get the x off the bottom of the fraction, so multiply by x, and then divide by cosine 80. And so x is going to be 5 divided by cosine 80, and at that point you can type that into your calculator. And I think it comes out to be 28.794 centimeters. So both of those congruent sides of the isosceles triangle, or the legs, are going to be 28.794. The base is 10. I think we can now find the perimeter. So the perimeter is going to equal 28.794 plus 28.794 plus 10, adding up the three sides. Altogether, that adds up to 67.588 centimeters. That's the distance around the original triangle. Quick reminder about angle of elevation and angle of depression. These vocab words should look familiar, but angle of elevation is the angle between your horizontal line of sight and the object that you're looking up at. So angle of elevation is like here, from your line of sight to what you're looking up at. And so that is an angle as you're looking up. Angle of depression is from your horizontal line of sight down to an object that you're looking at. So it's right in here between those two rays. Most common mistake that people make is they put the angle of depression here. That is not correct. So the angle of depression has to go out from your line of sight to the object you're looking at. Example 3. Suppose a tree 50 feet in height, so let's label that 50 feet in height, casts a shadow of a length of 60 feet. Now remember, shadows will be on the ground, so we'll put that down here. What is the angle of elevation from the end of the shadow to the top of the tree with respect to the ground? How far is it from the tip of the shadow to the top of the tree? So I think we actually have to find two different things. The first one is, what is the angle of elevation from the end of the shadow to the top of the tree? That angle will be right here, from the tip of the shadow up to the top of the tree. Let's start with that. Let's try to find x. So based off of x, what is the 60? Is it opposite, adjacent, or hypotenuse? Adjacent. What is the 50? The 50 is opposite. So then think about SOHCAHTOA, and you're going to choose the one that has opposite and adjacent, O and A. You're going to choose TOA. So tangent of, we don't know the angle, that's what we're trying to find, we'll call it x, equals opposite over adjacent, so it's 50 over 60. To solve this, we need to get rid of the word tangent. We're going to do that by taking the inverse tangent. So x is going to equal the inverse tangent of 50 divided by 60. This you can now type in your calculator, and you get 39.806 degrees. This is your angle of elevation from the tip of the shadow to the top of the tree. Second, they want us to figure out how far is it from the tip of the shadow to the top of the tree. So that is segment AB. from here up to here. Well, how far is that green segment? I'm going to call that lowercase c for now, because look what we have here. We have a triangle where we know this side is 50, this side is 60, and we want to find the third side, and it's a right triangle. Down in this corner, we have a 90-degree angle. Ha ha! We can do a squared plus b squared equals c squared. Little Pythagorean theorem. So the 50 and the 60 are your legs, so they go in for a and b. 50 squared plus 60 squared equals c squared. And then just keep calculating. So what is that? 2,500 plus 3,600 equals c squared. When you add those together, you get 6,100 equals c squared. And then remember, you have to take the square root. So the square root of 6,100 is 78.102. And I guess we would label it feet. If they label, you should label. Example 4. The figure shows a person parasailing. What is the height of the parasailer to the nearest foot? Okay, so we want to solve for x. We do have a right triangle down there. Now I want you to recall from geometry, if these two things are parallel, which we're assuming they are parallel, then when this transversal cuts through, you wind up with alternate interior angles. And if the lines are parallel, those alternate interior angles are congruent. So this corner down here would also be 36 degrees. That's important because now, let me highlight that triangle in yellow. So we're looking at this yellow triangle, which is a right triangle. All right, we can use trig. We can use our basic functions. And so think about what sides we have in relation to this 36 degrees. We're looking for x, which is opposite of that angle. We also have a 400-foot distance at the hypotenuse. So now think about SOHCAHTOA and pick one of those ratios. And you're going to pick the one with O and H. You should pick SO. So you're going to do sine of 36 equals opposite, which is x, over hypotenuse, which is 400. Then you can solve it by getting rid of that 400. So multiply both sides by 400. These will cancel out, and then it's just a matter of typing it in your calculator. So x will equal 235.114 feet. But if you read the question carefully, it does say round to the nearest foot. So x is approximately 235 feet. That guy's way up there. Whew, I don't know if I could do that, parasailing. Example 5. A plane is flying at an altitude of 12,000 meters. From the pilot, the angle of depression to the airport tower is 32 degrees. How far is the tower from a point directly beneath the plane, or in other words, the ground distance? So we want to find that distance down at the bottom that's marked as x. Think about your alternate interior angles. This is also going to be 32 degrees down here because of alternate interior. This is going to be our 90 degree, so we can set up our ratio. Go ahead and see if you can set up the equation for number 5. Go ahead and pause the video. So if you're choosing tangent, 32 equals 12,000 over x, you are correct. To solve it, you're going to multiply by x, and then you're going to have to divide by tangent 32 to get x by itself. Whatever you do to one side, do to the other. So x equals 12,000 divided by tangent 32. Now that can go in your calculator. I got 19,204.014, and it would be meters. One quick story. I actually have a friend who works at that air traffic control center in Farmington, kind of across from Schmidt-Mackey Arena. And I asked him one time, how often do you use like sine, cosine, and tangent a lot at work? And he said, every day, about 200 to 300 times a day. As an air traffic controller, he does problems like this, calculating angles of depression, calculating distances from runways, all kinds of things like that. He's like, I do it so often that I have most of them memorized. Like he has most of the, like we memorized 45, 45, 90, and 30, 60, 90. He has like all of them memorized because he does them so often. Number 6, a hot air balloon is floating above a straight road. The angles of depression to 2 consecutive mileposts are 15 degrees and 20 degrees. How high is the balloon? Okay, please pause the video and try to draw this picture. Draw the road, draw the hot air balloon, draw the angle of depression. Pause the video. We want to figure out how high up is the balloon. So we're looking for this distance right here. I'll call that X. That's what we want to find. When we dropped that down, we get a 90-degree angle down here. Now these are mile markers, these little tiny black posts, and so that means they're 1 mile apart. And so I'm just going to put that on here. This distance right here is 1 mile. We do not know the distance from here to here, so I'm going to call that Y. So you can see I've labeled X, I've labeled Y, and I've labeled the 1. This distance would be Y plus 1. So go ahead and put all of that on your picture. Think about alternate interior angles. So this angle right down here should be 20 degrees because it's an alternate interior angle with the other angle up above. This angle right in here should be 15 degrees. So keep those in mind as well. Again, alternate interior angles. We want to find X. So I'm looking at the smaller triangle on the left, and I'm thinking about the X, the Y, and the 20-degree angle. So here's what I know. The tangent of 20 degrees will equal opposite over adjacent, which is X over Y. Now think of the other triangle, the bigger triangle. And so the height on the bigger triangle is X, and the length on the bottom is Y plus 1, and the 15-degree angle in the corner. So if you think about that triangle, the tangent of 15 degrees is X over Y plus 1, opposite over adjacent. Now, if we only could know what either X or Y was equivalent to, then we could do some substitution here. So what I did is I thought, all right, I'm going to multiply by Y, and what I get is X is Y times tangent 20. I can plug that in. I can substitute this in to my other equation for X, because X equals Y times tangent 20. So I'm going to do that. So it's going to go tangent 15 equals, now instead of the X, I'm going to plug in Y tangent 20 over Y plus 1. And I'm going to try to see if I can somehow solve this for Y. So this Y plus 1 that's on the bottom of that fraction, let's see if we can get rid of that. So I'm going to start by multiplying both sides by Y plus 1. Here they'll cancel out. Next, distribute on the left side. So we're kind of distributing this tangent 15 times both of those items. And so we're going to have tangent 15 times Y. So we have Y tangent 15. And then plus tangent 15 times 1 is just tangent 15. And it equals Y tangent 20. And then I kind of started getting stuck. And so I thought, well, what else could I do? And I thought, wait a minute, if I type in my calculator tangent 15, I bet I can get a decimal. And so grab your calculators. Just nothing else, just type tangent 15 equals. You should get approximately 0.268. So imagine tangent 15 is 0.268 and it's got a Y next to it. And then over here you have another 0.268. Now we did round that off. Make sure you leave at least 3 decimal places. Now on the other side, go ahead and type in tangent 20 into your calculator. Tangent 20 should end up being 0.364. So we have 0.364 y over here. And suddenly I can solve this. Suddenly I have like terms. So minus 0.268y from each side. You end up with 0.268 equals, and when you subtract these, you get 0.096. 0.096y. Divide by 0.096, and we have y equals 2.792 miles. Oh my goodness, we have a distance. Let's put that on our picture. So the distance right here on y is 2.792 miles. Now go back to your original equation. I'm going to just outline it here in green. Here's my original equation up in that green box. Let's fill in the 2.792 for the y. So it's going to go like this. Tangent 20 equals x over 2.792. We can now solve for x. Multiply by 2.792 on each side. These cancel out, and now you grab your calculator and you type in 2.792 tangent 20. And x is 1.016 miles, and that is how high the hot air balloon is. Can you imagine being a mile in the sky? I have a little fear of heights, so that would not be very fun for me. It is not on my bucket list. All right, people, we're almost done. We're on the last one, example 7. Let's start by labeling everything that they give us here. They give us angle A is 20. So this is 20 degrees. They give us A to B is 32 centimeters. Angle E is 10 degrees. And B to C is 5 centimeters. We are supposed to solve for the distance from A to E. Remember, if nothing is above the AE, that means find the distance from A to B. So, or A to E, excuse me. So I'm kind of looking at this thinking we might have to do 2 separate problems and add them together. This would be a little 90-degree corner in the triangle on the right. So we have 2 right triangles. And I'm thinking if I could find the distance from A to D and from D to E and then add those 2 distances together, we could get the distance from A to E. I'm looking at the triangle on the left and I'm thinking I can find AD. So if I just use basic trig, I'm going to do, here's my angle, I have the hypotenuse of that triangle, and I need the adjacent side. And so think about SOHCAHTOA. If you have SOHCAHTOA, which one would you choose if you need adjacent and hypotenuse? You're going to choose cosine. So cosine 20 equals adjacent, I'll call it AD, over hypotenuse, which is 32. You could call it x if you want. Now get AD by itself. I'm going to multiply by 32. These cancel out. Grab your calculator, type in 32 cosine 20. And you should get 30.070 is AD. So I'm just going to kind of circle that for now. We'll come back to that. One of the problems I'm thinking about is on the right triangle, I don't know any of the sides. All I know is one angle. And so I really need to find one of the sides to be able to solve for DE. So I'm looking at my triangle on the left again, and I'm remembering that this side down at the bottom from A to D is 30.070 centimeters. So on that particular triangle on the left, I can do Pythagorean theorem. Think about this green triangle. I have 2 of the sides. So I can do a little 30.070 squared plus, I'll say, x squared equals 32 squared. 32 is your hypotenuse because it's the longest side across from the 90, so that has to be your C. All right, then just keep solving this. Go ahead and square the 30.070. And I just left that big long number in my calculator, so I just hit squared, and I got 904.215. 904.215 plus x squared equals 1024. And then subtract, of course. I try not to round until the very end if possible. So leave it in your calculator as long as you can. So 1024 minus 904.215 is 119.785. And then you have to square root. And when you do that, you should get about 10.945. So 10.945 is the distance up here from B to D. So then what we're going to do is we're going to take 10.945 and we're going to minus the 5 that's up. I'll do a different color here, right here. And we should be able to get then CD. So it's 5.945 for CD. So I'm going to put that on my picture. This distance right here is 5.945. I need to find this side, which is adjacent to the 10. I also have opposite with the 5.945. Opposite and adjacent goes with tangent. So the tangent of 10 is 5.945 over DE. Okay, this is kind of weird because I'm using two letters, but I'm going to multiply by DE on each side. And then I'm going to have to divide by tangent 10. So DE is going to equal 5.945 divided by tangent 10. And that you should be able to type in your calculator. And you get 33.714 for DE. We are almost there, people. We have AD, we have this distance, and now we have this distance. So to get the whole distance from A to E, we're going to add them together. So AD plus DE will equal AE. So here's our numbers. 30.070 plus 33.714 will equal AE. And that comes out to 63.784 centimeters equals AE. That was intense. Those last two problems, definitely intense. Hopefully, you can say I can apply right triangle trigonometry to application problems and that you can find missing sides and angles in an isosceles triangle. Next, you're going to do Unit 1, Practice 5. There's some tough ones on there, so if you get stuck, ask for help. We are here for you. Have a great day.